Introduction. What is force? What happens when a force is applied to an object? While pushing, pulling, lifting or hitting anything, we are actually changing the motion of an object. This change in motion requires force. So we can say that a push or a pull on an object resulting in its motion is called a force. Objectives. At the end of this lesson, you'll be able to define force, list the properties of force, understand the effects of force, distinguish contact and non-contact forces, list types of contact and non-contact forces, list properties of pressure exerted by solids, liquids and gases, list the effects of pressure on human activities, define atmospheric pressure. What happens when force interact? If you choose a heavy box and try to push it, the box will not move. Now if you ask a friend to help in pushing it in the same direction, it moves. This experiment proves that the forces are acting in the same direction add up. Effects of force. Consider a thin rubber balloon and blow air into it, the shape changes. Then tie its open end with a thread. Now press the air-filled balloon. You will see again the shape changes. This is due to effect of force. When you play football, the football is kept in the center of the field. When you kick it, it moves towards the given direction. Similarly, in the kitchen, your mother makes balls from dough and rolls them into chapatis. In this case, she is applying force to make them flat. Effects of force. One can change the direction of the object by applying suitable force on it. For example, in cricket, the speed of the ball hit by a batsman reduces to 0 when the fielder catches it. Also, if you kick a moving football, the speed of the football increases. Kinds of force. There are two major types of forces: contact forces and non-contact forces. Examples of contact forces are muscular force, force of friction, etc. Similarly, example of non-contact forces are magnetic force, gravitational force, etc. Contact forces. Can you push or lift a book lying on the table without touching it? Or can you lift a bucket of water without holding it? In both the cases, the answer is no. Generally, to apply a force on an object, our body needs to be in contact with the object. So we can say that contact forces are the forces which act on bodies when they are in actual contact. Basically, these are of two types: muscular force and force of friction. Muscular force. When we push an object such as a box or lift a bucket of water, then the force is caused by the action of muscles in our body. This force is known as muscular force. Note that muscular force is always applied either directly through touch or indirectly with the help of a stick or piece of rope. For examples, cutting the vegetable or fruits with the help of knife, hammering of nail with the help of hammer, pulling a cart by horse. Force of friction. Do you know why a heavy box on pushing does not move? Why a rolling ball stops after some time? When an object moves in contact with another object, a force known as friction comes into play. Note that the force of friction always acts on all objects and its direction is always opposite to the direction of motion. The moving object in the animation gradually slows down and ultimately stops due to the force of friction. This shows that force of friction always opposes the motion of one body over another body in contact. Types of non-contact forces. The types of non-contact forces are gravitational force, magnetic force, and electrostatic force. Do you know why the leaves of fruits fall to the ground when they detached from the plant? This is because of gravitational force. The force due to Earth's attraction is called the gravitational force. This is an example of non-contact force. Now the force between two magnetic poles placed at a suitable distance is called the magnetic force, in which like poles repel while the unlike poles attract each other. A magnet can exert a force on another magnet without being in contact with it. So, the force exerted by a magnet is also an example of non-contact force. Do you know, when we rub a tube through dry cloth and bring it near the thread is attracted towards the tube. This is because on rubbing the tube through the dry cloth, an electrical charge is generated on the tube. This is called the electrostatic charge. This is also an example of non-contact force. Pressure. Let us perform an activity. Take 5 wooden boxes of almost the same size. Fill them with scrap iron to make them heavy. Arrange these boxes on a wooden table, placing them side by side. See the impact of the push force from these boxes on the table. You will notice that the table remains normal and it is not affected by the push force, that is, weight of boxes upon it. Now, rearrange these boxes on the same table, placing them towards the center and one over the other. Now see the impact. In this arrangement, the table either bends or breaks under the weight of boxes. Can you guess why does this happen? Though the force applied in both the cases is same, but in the first case, impact is less, and in the second, the table bends. This activity proves that both the force and its coverage area are important. The smaller the area on which the force acts, greater is the impact, and this phenomenon is known as pressure. We can also say that pressure is related to the force. Daily life example of pressure. Have you ever noticed that why school bags have white straps? Why sharp knife cuts better as compared to blunt knife? And why the tip of the needle is sharp? In our everyday life, we all experience the impact of pressure. A school bag has white straps so that the weight of the bag may fall over a large area of the shoulders of the child, thus resulting in less pressure on the shoulders. And due to less pressure, it is quite comfortable to carry the heavy school bag. A sharp knife has a very thin edge. It cuts objects better because the area of contact is very small. The force of our hand falls over a very small area of the object, producing a large amount of pressure. And this large amount of pressure cuts the object easily. Due to its sharp tip, the needle will put the force on a very small area of the cloth, producing a large pressure sufficient to pierce the cloth being stitched. Do liquid and gases also exert pressure like solids? Do you know what happens when you blow air into a balloon? It exerts pressure in all directions. That's why the balloon increases in size and shows equal enlargement in all directions. The same is also true for the liquid. It also exerts equal pressure in all directions. When a plastic disc is submerged in water, it does not fall down. It is continuously pressed against the glass pipe by the pressure of the water. This implies that the water exerts pressure in all directions. Air and our atmosphere. We know that there is air all around us. This envelope of air around the earth is known as atmosphere. Actually, air has weight and therefore exerts pressure. The pressure of the air upon the surface of the earth is called atmospheric pressure. Note that atmospheric pressure decreases as we go up and up. On an average, the weight of air on our head is 1 kilogram per centimeter square. Daily life experience of atmospheric pressure. In our day-to-day activities, we experience various instances of atmospheric pressure. Some common examples are sipping cold drink through a straw, dipping the nozzle of the syringe in the liquid, or filling of ink in fountain pens. Do you know what happens when you sip the cold drink? The air pressure inside the straw is reduced, and the air pressure on the surface of the drink pushes the drink up into the straw to reach our mouth. In case of a syringe, the doctor dips its nozzle into the liquid and pulls the piston, thereby lowering the air pressure inside the syringe. Another example of ink-filled fountain pens that have rubber tubing, the rubber tube is pressed to push out the air from it, thus reducing air pressure inside the tube. Drag and drop the options to their right places. Summary. Let us summarize what we have learned. Force is a push or a pull resulting in motion of a body. Force can change the shape of an object, move an object from the position of rest, change the direction of a body in motion, and change the speed of the moving object. There are two kinds of force: contact force and non-contact force. Muscular force and force of friction are the examples of contact forces. Gravitational force, electrostatic force, and magnetic force are the examples of non-contact forces. Force per unit area is known as pressure. Pressure from solids is due to their weight and acts downward, but in the case of liquids and gases, the pressure exerted by them is downward, sideways and upward also, that means in all directions. The envelope of air around the earth is known as atmosphere. The pressure of the air upon the surface of the earth is called atmospheric pressure.